One of the most important tools you can have in your tool bag is an appropriate volt-ohm meter or a combination multimeter that includes amperage. Now, it's not only important to have the right meter that has the right features, but you need to know how to use each of the settings on your meter. So you see we have 3 different meters we're going to look at here today. To start with, we're going to look at this meter. Now, a couple things to notice is that it has the amp jaw here, can measure amperage, and with a push of the button, that can open and close to go around 1 wire at a time. Only 1 wire. If you clamp around 2 or more wires at a time, the flux lines will cancel each other out and you won't get an amperage reading, which could be unsafe. As we look at the rotary dial here, there's several different settings on this meter that we can turn to. We're just going to go clockwise. From the off position, we're going to go to the left. And what you'll see here is that on this meter, we read VAC or volts AC. We can also read hertz or frequency. Now, when this meter is powered up, it has a dual line display. It'll show voltage on one side and the frequency or hertz on another, which is great for testing inverter circuits or variable frequency drives. Moving next, we have the volts AC scale. And this one is volts AC, but notice it goes up to 600 volts AC, and it does frequency as well. Now, as we look down here, the next setting on this specific meter, it has a hertz and a percentage sign. So this is going to give you a percentage of total energy consumption. Down here, there is a setting. It has the inverted U or the smaller case U and ADC. This is for microamps DC. Now on this meter, we have an L1, 2, and then an L1, 3. This meter can be used for 3-phase motors to check the phasing to make sure the motor is going to run in the right direction. Moving over here to the next spot, you have an F or a C, T1 and T2. This meter has built-in temperature probes that you can utilize to measure not only one temperature, but 2 temperatures and automatically calculate the delta T or the temperature difference. Something important to note is when you're using a multimeter that has volt leads and temperature leads, you want to make sure that one of them is disconnected at any time. In other words, you don't want your voltage leads to be in at the same time as your temperature leads. If those leads touch together, they can create a short that can damage the leads or the meter. To prevent that, on this specific meter, if you remove your meter leads, there's a switch right here to switch it to temp. If you don't, you'll notice that there are some gray shields in here that prevent you from being able to insert the K-type thermocouple. Flipping this switch to the opposite position now locks you from being able to use your meter leads, but allows us to insert the K-type thermocouple for temperature readings. The next setting on your meter is microfarads. This is for testing capacitors. Now, in inverter-driven machines, you're most likely not going to test the DC capacitors that are on the control boards. But if you have any AC components, an AC motor, you're going to need to test those individual capacitors that help them run more efficiently. The next scale up is NCV. This stands for non-contact voltage. That's going to allow you to use this like a voltage stick. If you take the head of the meter, right here where you see the lightning bolts, near a wire, it will illuminate and create a beep to let you know that that wire is still hot. Now, do not use that as a voltage source or to test voltage. Use that as an alertness or an awareness meter. If this goes off, take and connect your voltmeter leads and check the circuit to see if it's live. The next setting here has multiple settings for it, and you would use the select button to change. The first one is the horseshoe or the Greek letter omega. That's for resistance. We would use that to ohm out a motor, a compressor, a contact, a switch, whatever it might be. The one above that is a beat or a audible pitch, which is going to give you continuity to let you know when you test your meter leads across the load, if it beeps, there is continuity. Now, don't get overconfident in the continuity tester. It'll tell you that there's continuity. That does not mean that the resistance is right. If you have a stranded wire that has 60 strands of wire wrapped together, all continuity will tell you is at least one of those wires is connected from end to end. If the other 59 are broken, you're not going to allow that thing to pass the proper voltage or the current. The next step up here is what we call a diode tester. This is critical to have a diode tester to work on mini splits or VRF components. Because if you have to check the output of an inverter board, you're going to plug your leads in, you're going to look to the manual to see where the black lead should go and where the red lead should go, and you're going to initiate a diode test to check that diode to make sure it's firing at the proper rate. If your meter does not have a diode tester and you're working on a mini split or VRF product, it might affect your ability to troubleshoot the system properly. Now the last setting on this specific meter is W for wattage. What that allows you to do is plug in your leads down here, and utilizing some alligator clips, you can clip onto a voltage source, L1 and L2. You can read voltage. You can take the amp jaw, you can open it up, and you can put your wire through the middle, and that will measure amperage. And of course, if we multiply voltage times amperage, we will get our wattage, so we can check that. Now, the other things on this meter are more of a convenience or an aid to help you. One of the things I like about it is the ability to have this head that rotates. So if I need to go through a wire here, I can rotate the display to still easily see my values. It's backlit, so it has a backlight to be able to illuminate the display. It has wireless on or off. The specific meter has Bluetooth to your app on a phone or a tablet, so you can read the readings and even record data onto your app. The range button allows you to cycle between the various ranges. If you don't touch this, the meter will auto range and find the voltage amperage that you need. You do have 2 temperature clamps down here, or 2 temperature connection points, where you can utilize a K-type thermocouple or a clamp-type thermocouple to measure temperature. Other thing that I want to show you on this meter when you're going to use it. If you are going to measure amperage, what a lot of people do is they put the meter on the wire and let the wire hold the meter in place. That's not the appropriate way to measure amperage. A wire with current going through it has flux lines or magnetic fields of force that we're going to measure, and that's how we measure amperage. If the wire is touching any one side of the amp jaw, it's going to minimize the signal and you're going to read lower than you normally would. If you look on the meter, there's a symbol here, here, and here. These are what is known as crosshairs. They're telling you to get the best amperage reading, the wire should be in the middle of that symbol. Okay. So that's one of the meters that we look at. If you wanted to see another side of those crosshairs, here they are. Here's 1, 2, 3. You want to make sure your wire that you're checking amperage on goes right through the middle. That's going to give you the most accurate measurement. Okay. This one has a magnetic strap, and the reason I want to show you this is if you are going to use a temperature meter, you will from time to time need to calibrate that meter to make sure it's reading a true temperature. Removing this screw and this screw will give you access to a potentiometer back here, and what you'll do is you'll take your temperature clamp or your K-type thermocouple, submerge it in ice water. You want that water to stabilize out, because anytime we have ice and water, it's a saturated mixture, and we know it's 32 degrees because that's the melting point of water. Immerse your thermocouple and then adjust your potentiometer until you read 32 degrees and you know you've got a properly calibrated thermocouple. The other feature of this strap is it does have 2 magnets. This allows you to magnetize the meter to the panel that you're working on for a hands-free connection. Now that we've taken a look at this meter, let's look at a different meter by a different manufacturer to show you how the symbols and the features may vary. Here we have another meter with similar characteristics and similar functions, but a slightly different look and feel. Now as we look at the dial of our meter, this is the off position. We can go here to this setting and you see the A on this meter, that stands for amperage. And if you see the 2 lines above the A, one straight line and one squiggly line, that means that the amperage is alternating, or AC current. That's going to be your AC amperage. As we go up one more value, we see voltage with the squiggly line above it. That means that's AC voltage. And notice the C and the F. If I were to change the select button here, I could change that from reading voltage to reading temperature. And I'll show you how this meter reads temperature in just a moment. Going up to the next scale, we have the omega symbol or horseshoe symbol for ohms. We have the symbol here with the triangle and the line indicating a diode that only allows voltage to pass in one direction. We have the sound beep or a signal indicator here for continuity. And then over here we have a lead or a meter or a symbol that looks almost like a contact. This on this specific meter is actually your microfarads for testing capacitors. The difference is when we looked at the other meter, one of these vertical lines had a curve in it representing a capacitor. For some reason this manufacturer chose not to use that, but this is where your microfarad setting would be. It's critical that you read the manual that came with your meter to know exactly how it functions. As we look up here, you see the U and the A. The U stands for micro, the A stands for amps, and right above it we have the straight line and the squiggly line. So this is going to tell us that that's alternating current. This is alternating current in microamps. Very small signal, typically used to diagnose a flame sensor on some gas furnaces, and that's what that's used for. Now the next setting up here is your watts. So with this meter, you can again use alligator leads or clips to put your meter leads on a known voltage source. You can open up the meter and you can put this around the wire in the center to measure amp draw. And I just want you to notice again here, there's 1, 2, 3 crosshairs. This 1, 2, 3 crosshairs is indicating that that wire should be in the center to measure current properly. Not here, not here, and not here. It's all too easy to allow the amp meter to hug the wire and hold the meter in place for you. Just know that your value will be slightly off. How much depends on the current that you're measuring and the circuitry that you're working on. Now as we look at this meter, it has a couple other features that are important to know. This button right here will enable your backlight display. It also has a Bluetooth symbol. This meter, like the other one, has an app that you can Bluetooth to read your measurements on your phone or tablet and record values. It's important to know. This button on the far right side is for min and max settings. This allows you to capture the minimum and the maximum value of anything you're looking at. Not to be confused with the inrush button. Now inrush is used to measure the starting current, or how much current a load will pull on startup, which is always greater than continuously running current, because it takes more energy to get something in motion than it does to keep it in motion. If you want to know the lock rotor amperage, the LRA, of an AC motor that's starting up, you cannot use the min-max because that's going to give you a minimum and a maximum. You need to use the inrush. That's going to capture the true starting current. So those are some important features on this meter. Now one last thing I want to show you, you do need to understand your meter. As we noticed up here, this one will measure temperature in Celsius or Fahrenheit, but as you look at the meter, there is no port to connect a K-type thermocouple. This type of meter requires a special adapter, like the one that we see here, that can plug in to the common and the voltage terminal and gives you your K-type thermocouple or your pipe clamp. There's various adapters like this. This one has the K-type thermocouple connected to it. Others will connect to your meter leads and have a slot right here to plug your K-type thermocouples into. So again, similar functionality, but the symbols change and how to use those symbols is different. We're going to look at a third meter here. This is a very common meter used in the industry as a bench type meter. This one's by another manufacturer, so we have our leads here. And as we look at the settings, we have auto for voltage. We have off. Here's the V with a squiggly line, so that's AC voltage. In yellow, if I switch the yellow button, that'll give me my hertz value, my frequency. Here is voltage DC by the straight line and the broken line, meaning it's direct current. Here we go with millivolts AC, or if we push the yellow button, we'll get millivolts DC. The omega or horseshoe symbol is for your ohms. This symbol here is the symbol of sound leaving a speaker. This is your continuity setting. And here you have the capacitance symbol Notice that this manufacturer is using the curved edge for capacitance. And then if I push the yellow button, I read my diode. This setting here is for your temperature setting. Notice that instead of the letters C and F, they use this symbol which is supposed to represent a mercury bulb thermometer. So you want to be aware of that. Refer to your manual for the different indicators that will show you what to use. Like the previous meter, this does not have a slot for a K-type thermocouple. That adapter would need to be snapped into these terminals here. And they are polarity sensitive. Make sure that the common goes to the common and that the red goes to the red or the positive. And then down here, this meter has the UA, so that's microamps. And you can see here that it's AC with the straight line and the squiggly line within the yellow, which would mean I need to push the yellow button, or it's DC with the straight line and the dash line. That's the overview of this meter. Now, the one thing this doesn't do is measure amperage. So somebody using this meter would also have to have an amp meter in their truck or in their toolbox, or they could utilize one multimeter that has both. Whichever you prefer is up to you. Just know how to use your device. We'll look at a couple more accessories real quick for meters and just be aware of how they work. Now, when you're working with mini splits, you definitely need micro leads. Those wire harnesses that we use have very small terminal connections, and you need to plug into these. Now, which micro leads you use will depend on the meter you have and your preference. I prefer to use these leads here. If you notice on this lead, there's the micro lead and there's the standard lead. It has a protective case on it so that if you're working with higher voltages, you don't have the full lead exposed to reduce the potential for you to shock it or hit another circuit and ground out your meter. But on this meter, if I want to use my micro leads, I simply disconnect my high voltage lead or my larger lead, remove the plug from the bottom of my micro lead, and it snaps right into place. You might have two separate sets of leads, or you might use this. Whatever you prefer, it's your choice. But if you're working on mini splits in VRF, you're going to want micro test leads. Now, we talked about using alligator clips to clip onto a known source of power. Now, to do that, you have a couple different ways you can do it. You can have leads that have alligator clips built into them, or if I'm using this style of meter lead, again, I simply remove the plug, connect to my existing lead, and go there. So that gives me the ability to have alligator clips on. Now, as you're troubleshooting an electrical circuit, one of the most important things to do is keep your hands out of the circuit, which can be difficult if you're using a voltmeter and you're using two leads to check for voltage. You're going like this, you're putting your leads in and you've got both hands in the circuit, which means that if you get yourself across the load and you short yourself out, current will travel up this arm, right through your heart, and come out this hand and cause you a very troublesome shock, if not fatally harm you. So one of the ways to overcome that is to utilize what we call the hopscotch technique. And to do that, I'm going to bring this meter back in play. I'm going to switch the temperature switch back over to meter leads, and I'm going to connect my leads here. Now I could set this meter to voltage if I was using voltage, and I could, if I wanted to, stab and grab through the circuitry with both hands, but I run a risk. Another way to do it is to take this lead off and get your alligator clip and clip to a known circuit. Clip this on your L2 wire and leave it there. Because whenever I read voltage, I'm reading a potential difference, which means a difference between L1 and L2. Clip this onto L2. Now with one hand, I can go into the circuit across my wires to see where there's a voltage loss or drop. And that'll give me the ability to troubleshoot. Now if you want to be extra safe, there are other options you can use. This specific meter has a clamp on the side where I can slide my lead in, and now with my black lead clipped on L2, I can stab this way into the electrical circuit, look at the face of my meter, and see what the voltage is. This way I don't have any hands in the control box. You can rotate the head so that you can put the meter lead any way you want and still be able to see your display. Now these features, that all depends to you. which brand you are most comfortable with, and which brand you feel is most reliable. The key thing is to know how the meter works, know the settings, and know how to use those settings to diagnose and troubleshoot systems. As systems become more complex, you're going to utilize more of these settings. So I hope you found the video informational, and I hope you can use this to aid and help you troubleshoot HVAC systems. Thank you.
For service manuals and other documentation, please visit our website at samsunghvac.com or use our Samsung HVAC mobile app to download any technical documentation. Thank you.